All right. Hello, everyone, and thank you for joining us today. My name is Daniel Nguyen, and I will be your host for today's webinar. Today's topic is a systems architecture and modeling challenge. It is a recap of the first annual World Championships competition at Integrate 23. Now, given the number of participants today, I can see that this is a topic of great interest to everybody. So with us today, we have two great speakers whom many of you may recognize. So before we meet our speakers, there are a couple of housekeeping items that I need to cover. First, we are recording this webinar for your reference later. Second, you will see a control panel typically on the right side of your screen. You are muted by default, but we encourage you to ask questions. So please submit your questions in the question window, and we will answer them during the presentation or during the Q&A session at the end. And lastly, we asked 3 poll questions during the webinar today, and we will share the results with you so that you can see how others respond as well. So watch for the pop-up window, then it's time for when it's time for the polls. All right, so today we are joined by Michael Vanacek and Rick Steiner. Michael is the Digital Architecture and Requirements Engineering Director at SAIC and an adjunct professor at the University of Detroit Mercy and the Center for Engineering and Industrial Development in Mexico. Michael has over 30 years of automotive and defense engineering experience. And presents regularly at national and regional conferences. Michael has contributed to several books, most notably Taguchi's Quality Engineering Handbook and the MBSE chapter for the 3rd edition of Systems Engineering, Principles and Practice. Michael is a fellow of the Engineering Society of Detroit, the president and founder of Sigma Theta Mu, the Systems Honor Society, and the current treasurer of INCOSE. Rick Steiner is an INCOSE fellow and expert systems engineering professional, model-based systems engineering coach, and the contributor to both the SysML v1 and SysML v2 specifications. Rick spent 30 years as a systems engineer at Hughes Raytheon and is now a lecturer at the University of Arizona. All right, so this is how we plan to move through things today. So let's take a look at the agenda. So we will begin with an overview of the challenge presented by Rick. Then Mike will speak about how he approached the problem and what it was like to compete. Then Rick will speak about the experience of being a judge, and then we'll take questions. We also have 3 poll questions that we will ask throughout the webinar. You will see them pop up when the time comes. Then just click on your answer. It's all anonymous, so and you can see how other answer the questions as well when we close the poll. All right, so welcome, Mike and Rick. Thank you for being here today. So let's go ahead and get started. I will hand this over to you, Rick.
Okay, so as I thank you, Daniel, for introducing me. This was actually a great opportunity. The first time anybody has tried to do a short challenge like this for model-based systems engineering or for system architecting, system modeling. I don't know if it was Enrique Krajmaljenk or if it was Brian Selvey came up with the idea, but they worked together on it. They invited me to be a judge. And you know, it's very unique. I've never seen this happen before, and so that's why they call this the World Championship, because nobody's ever done it before. But it was a really interesting idea, and so I'm glad to be a part of that. I'm really glad to be a part of it. So let's see if I can advance. There we go. I'll advance the slide here. We'll talk about first of all, we'll talk about setting the stage with the structure of the challenge. I'll try to explain the problem statement to you as kind of an overview, and then I'll try to you know, then I'll pass back over to Mike, and he can talk about his winning submission. And then I'll talk about what it was like to actually try to grade these all and make the award. So, as you might expect, it was not as simple as that. Okay, this is just the schedule for the day. It was very compact. As you can see, the actual contestants really didn't have a whole lot of time. You know, from 8:30 in the morning till 2 in the afternoon, and then it was pencils down. So they really didn't have a whole lot of time, and that becomes an interesting aspect to the dynamic of how each competitor, whether they be an individual or whether they be a team, would approach this problem. It was really important to be able to cover all the bases very, very quickly, and so so that made this challenge really interesting. Okay. So here were the basic rules. They were provided Wi-Fi. They were provided. They had to bring, each contestant had to bring their own computer to work on, and they had to bring their own software that they were going to use. And so there was no restriction on which system modeling tool they were provided. And we can talk about how that panned out in a moment, or when I do the overview of the results. The individuals had to make sure that all of the tools that they brought were properly licensed and that they had everything they needed. They were allowed to use the Wi-Fi to do additional research if they wanted to and add into the problem statement. Although I will say the problem statement, at least in my mind, was pretty darn well formed. And we'll talk about some of the interesting things that one of the teams did with respect to that as part of the wrap-up. Any modeling tool, any modeling language, any methodology, as long as, well, you will be judged on how well structured your model is, of course, as well as how well structured the solution is. And so hopefully that's kind of making sense. Okay, you could bring some previously developed templates or rule sets or whatever to aid in modeling consistency. That played a role as well. Okay, but you couldn't bring a bunch of previous models and then just patch something together. It really had to be produced at the event. So those are the basic rules. Okay, these are the judges. It's interesting how I think it was really brilliant how Brian and Enrique came up with this this panel, because I was there representing a modeler, a modeling coach, someone who understands system modeling applications. Enrique Correa was there to represent someone who's really familiar with how analysis happens and analysis tools, how to connect analysis tools together and how to drive toward numeric solutions. And so he had a very important role to play. John Zellen is a very distinguished program manager that's done a lot of advanced technology programs. And so he provided an excellent program management aspect to the review. So I'm really glad that they were all involved. We made a really good team. Okay, and of course Daniel was there and Paul was there to help make things happen. This is the awards that were advertised. A model of the year, which was an individual award, a modeling team of the year, separate for those groups that modeled as teams. Of course, as a team versus an individual have a little bit different dynamic. And then there's I won't call it a consolation prize. I will say, if all we're going to judge on is how innovative the solution was, as opposed to how well it covered the problem or whatever, right? there was a third award for most innovative, and that actually became important at the end. And we'll talk about that as well. Okay, the basic background. Brian did a fantastic job of characterizing a problem in the Southwest United States that is pervasive. The population of urban areas in the Southwest, and particularly in Arizona and in Southern California, populations are growing rapidly. Water is becoming more scarcer to support those greater populations, and of course, power is becoming more difficult to provide for increasing populations. And so the problem statement centered around those three things. Okay. Now, originally, Brian did a lot of work researching the area of the Santan Valley in Arizona and a little bit farther north in Scottsdale, some of the problems they were facing. He actually talked to some folks in the city councils of those areas. We decided, though, as a group, when we were trying to pull this together with the judges, that it might be better to have a completely fictitious city that represents the kind of problems that the Santan Valley is experiencing in terms of growing population and not enough water, not enough power. And so and I suggested that, well, just to make it a little bit easier, why don't we make it near the coast so that there's seawater available and a port available, so that can expand the problem space just a little bit, so it's a little bit more solvable. But this is the geography that Brian came up with, and I'm very pleased that he did it this way, because it really presents a lot of interesting little possibilities for how to address the problem of this fictitious city, Mesa Cerveza, beer forward. It's interesting. It's kind of amusing, but it was actually a well thought out problem. Okay, so this is the specifics, which you can go look at later if you're interested. It is representative of the kind of problems that are faced in in South Central Arizona, as well as parts of New Mexico and parts of Southern California. And it's talking about the reservoirs that are there. It's talking about the population growing dramatically in the next 30 years, and what are we going to do about that, and how do we handle that? And so the basic problem statement is that each contestant represents this company, Eco Solutions LLC, which is going to develop a comprehensive system solution to these challenges, and provides the anticipated water and power needs for the city between 2030 and 2050. And you can see that there is a budget, 900 million, and there's a risk if you want to exceed that budget, because you'll have to have some initiatives passed to draw more money, and etc. So that's the basic problem, rather than getting into the details of it. There's a statement of work specifically for what the city of Mesa Cerveza wanted from, and that is a kind of a mission needs statement that can be used as a basis for requirements development. The presentations had to be in PowerPoint, MS Office products, basically. Now, a lot of people would prefer to present from a model, but in order to make it a little more fair, so we didn't have some people who were very, very good in presenting out of the model, and some that weren't, we said, no, just make it in MS Office, and if you want to supplement that with your models, that's fine. Many of the, we'll talk about how those actually went a little bit later, okay? The last thing I want to show you here is the judging rubric, and this we had kind of come up with in advance, and we had to kind of tweak it while we were actually doing this. But you can see here the kind of things that we were concerned about, and I believe we did share this with all of the contestants ahead of time. Basically, out of 100 points, I would expect you need to be able to address the needs and the requirements. I want to see a good requirements decomposition. I want to see a structure of requirements and how that maps into your solution. I want to see some sort of functional architecture. I want to see not only in terms of what are the functions, but how do they trace to the requirements and the constraints? I want to see a physical architecture. How do you deal with multiple solution architectures? How do you deal with trade studies? How do you trace your physical components back to the requirements and the functions? I want to see some V&V kind of things. How are you going to test this thing? How do you make sure that it's actually going to be on track? How do you trace the validation plan, verification plans back to your originating requirements? There is this 10 points for innovation. You notice it's only 10%. Okay, that's one of the reasons having a separate innovation prize I thought was a really good idea, because in general, there's two ways you can go. You can try to be as innovative as possible, or you can try to be as risk-free as possible. Innovation also always involves risk. So this was an important aspect to the project, to the competition, and I will tell you about that when I do the wrap-up. Risk was also important, and I shouldn't comment on who did what, but it did play a role, not a huge role. 10 points, 10% is just the aptitude of the modeler. Was the model well constructed? And then 15 points on how well they did on their debrief in terms of communicating the results, okay? So with that said, what I'd like to do now is stop sharing and turn it over to Mike and let him give you his outbrief presentation. We good for that?
Thank you. Thank you, Rick. Now, before Mike starts, we will have a poll question. So let me launch the poll question. So do you consider yourself a highly motivated competitor who enjoys the pressure and the tension of a fierce contest? All right, fantastic. So let me share the results. So very interesting. We have a little bit of a middle of the road result here. So this poll is just to let us put ourselves into the competitors' shoes right before they enter the contest. So with that, I'll hand it over to Mike.
Thank you so much. Before we get started, it was a real pleasure to contribute and participate in this. So I actually came with a team that participated in the team event. And so before we actually started, we had a brief strategy session and realized that we needed to save time for plating. If we were talking about this on Chopped, like on Food Network, you need to save time to present your work to the judges. So given the constraints we were given, I made sure to save time for that, and so did my colleagues. And so just as we move into this, I want to explain what I came up with. This is my actual presentation that was given. And I realized that this was obviously a problem outside my normal area of expertise. I have automotive and defense experience. I typically have my students model space systems. So my hat was off to the Integrate team for coming up with a problem statement that was real life and also something that most of the competitors probably didn't have detailed domain experience about. So it would be a true test of modeling aptitude. So my goal as I studied it was to come up with a credible enough solution because I'm not an expert, and then to play to my strengths. For example, past thesis students have done very well at the NCOSE and gotten best paper doing some non-traditional add-on analyses to a traditional architecture. So I wanted to give a taste of the fact that the architecture model could be used for some useful additional analyses. So with that, this is my Mesa Cerveza analysis. So I led with a boiling down what the key goals were. For example, making sure we met the water and electrical needs. The statement of work explicitly said they could handle their own land acquisition. And my model was basically set up as a stub with hooks for simulation and analysis experts. So I was trying to showcase the architectural setup that would enable trade studies and other things. I was trying to make sure I had a complete, consistent, traceable architecture and also have this quality of life analysis versus via a freedom index concept to show that based on restrictions imposed on the population, how much of their freedom we'll be able to preserve with an individual solution. So the architecture I settled on was to leverage the sea that Rick had mentioned, use the adjacency to the Sea of Java to get desalinization going. The intent there was to also look at a micronuclear grid. And the interesting thing that I found, a technology under development that basically just needs heat to run the desalinization. So the waste heat from the micronukes would actually ensure efficient desalinization. We could conduct or construct any number of wind or solar farms as needed, and then use an aqueduct pipeline to transfer this water to Mesa Cerveza, with the provision that we could negotiate water rights from the existing sources. The statement of work said we did have the right to pull water from some other sources in the interim, but again, my belief was that this desalinization, the only effectively limitless supply of water available was that sea, and so that's why my focus went there. So again, there's no upper limit on the available water. It was as carbon friendly as I could make it, and ultimately it would ensure energy and water independence for Mesa Cerveza. So this technology that I found through MIT basically just uses very low cost materials. A square meter of it could provide for a family's drinking water, and it only costs about $4, believe it or not. So I made some fudge calculations here with assuming how much it would cost, multiply it by 5. It only would cost $4 million to make a plant large enough to support the 2050 population. And then I even padded it further with risk mitigation for tech development and the increased size. So again, I did my best, again, not being an expert in the domain, to at least make some conservative estimates on actual development costs for this technology. So basically put this together. We were given the cost for the aqueducts, and I found some costs on the micronukes. So I came in under the $900 million budget. Obviously, real life analysis or trade studies could probably sharpen the pencil a bit, but at least I was confident that I had something feasible that I could then go forth and model. There were some risk mitigations I explicitly looked into. The Israelis do a lot with risk desalinization, but it does have higher energy costs. There's also some other rainmaking technology being done by the 5-Hour Energy Drink founder. So the presumption was if our main desalinization technology didn't work, we could fall back on one of these. And the same thing with power. If the microgrid or micronukes weren't feasible, we could look at solar farms, wind, natural gas, any number of traditional plants to resolve that. So that was the intent. So basically, I also put together a test architecture showing that we would build out a test desalinization plant, along with some properties like its construction cost per cubic meter of water purified, basically showing I was putting hooks in to drive automated trace studies and analyses, and showing that it takes in salt water and puts out fresh water effectively. Now, in terms of the model layout, I went ahead and confirmed with the judges that using the SAIC freely available and downloadable to anyone validation tool set was legal and legitimate in this context. It didn't have any pre-canned content directly related to the project, and so that gave me access to the validation rules that we give away, as well as a model template that had this structure. Now, I could have easily recreated this in probably 5 minutes if I hadn't been allowed to use it, but that did save me a teeny bit of time. And the important thing is to show the layout of the model follows my normal thought processes. So, capturing source content, doing any behavioral analysis, use case type diagrams, functional architectures if necessary, logical, physical, verification methods, any analysis type parametrics and such, any derived requirements, and then some supporting content. So this is how I think of constructing a model. Again, helps me frame my thoughts. And so, taking the requirements from Mesa Cerveza and their statement of work, we basically had 2 functional requirements to generate electricity and provide potable water, and there were a variety of functions that could provide that. So again, as I began building the model out, my normal approach and the rules require functional requirements to be satisfied by given functional elements, operations typically, or activities, and then have a tied verification. So the rule set that we give away automatically drove me towards meeting the needs of this contest as I continued. Then I built in a variety of other requirements showing the different power needs at the various points in time as specified, and that they would be satisfied by various value properties within the model. So the performance requirements are tied to individual value properties, and again, they would be verified by analysis in this case. Same thing with water needs. So again, this caused a rapid proliferation of value properties in the model, but these would then be used by analysis teams doing trade studies and other things. So the architecture was fundamentally sound and was able to provide places to store all this information. This is just a view into the model that I presented to the judges. So you'll see the requirements on the left, the text. Again, if this were a real project and we had more time, it would be more elaborate than just saying meet 2019 power needs. But fundamentally, I captured the intent, showed that the performance requirements refine a specific functional requirement. That's just the modeling pattern that I prefer, because to my thinking, a performance requirement is meaningless without having the functional requirement that it discusses. And so those are all tied together. Notice we have a requirement, a business requirement at the bottom, to not inhibit the natural population growth of the area, that we should allow Mesa Cerveza, as people wish to move there, to not be inhibited by lack of water or electricity. And again, these are traced to various aspects. In many cases, it's the Mesa Cerveza statement of work. You can see the satisfaction column showing the various functions and value properties that satisfy the requirements. Note that our rules also force value properties to be typed. So in this case, I've said kilowatts is my unit for measuring power needs, and then the verification. And in the case of the potable water, it's analysis and pilot plant testing. In the case of the rest, it's simply analysis. So how did I consider looking at the behavior required? So I modeled out a few use case diagrams just to make sure I had some high-level views of the situation, including, if you look carefully, there are some hazards in there. So I decided to attach our free failure mode effects analysis profile that provides hazards and other things. And so looking at population dissatisfaction, power shortages or water shortages as possible undesired outcomes. So these are basically treated as extended use cases with extension points, but it lets us capture the fact that there are some undesirable outcomes possible. Notice we have a variety of other things captured in the context, including property restrictions, lifestyle restrictions, taxation, so non-traditional, not system elements per se, as well as the various lakes, and seas and other sources. So again, this is what helped me establish the context for the later architecture, because the modeling pattern I use requires anything that shows up in a use case diagram to be a part property in the overall context element for the model. And so zooming in on the quality of life use case, again, notice we're looking here to understand the impact on commercial and residential customers to maintain this quality of life. Again, we have to support the population growth, but again, there's the possibility here for population dissatisfaction if there are tax increases required or other limits. Same thing with the power shortage. Again, just to zoom in on that other diagram showing more about the electricity use case. And again, the provide potable water, again, noting that we could either have excess water or a drought depending, and again, water shortages would be tied to the drought. And again, you can see the various sources of water available to the city. So building out the logical architecture, this was the compact view, a realization matrix, again, showing full traceability from the part properties of the system context to any use case actor. So that's the first handshake that happens inside our modeling style that I've developed with my team, is that we have to ensure that anything that shows up in the use case is represented in the architecture. And you'll notice that the corporate tax rates and freedom indexes and such, those are properties that are allowed to realize environmental conditions, but everything else is pretty much treated as an actual system. So again, full traceability at this point to make sure the logical architecture is off on a good foot. And then looking at the functions that the various systems provide. So again, there's a lot of things that consume various resources and produce electricity. So again, just showing that I have the ability to meet these needs, to provide electricity, natural gas, fresh water, etc. Now, I will say that as I proceeded with this, it's normally my natural inclination to fully model out internal block diagrams and nail my flows and everything to make sure that the architecture is fully consistent. Unfortunately, I didn't have time to do that. This was a very tight timeline. And so I really had to stop at one point and stop some of my internal block diagram work because I wasn't going to be graded on it. I needed to deliver what I was being graded on. It's like being on Chopped. I may like to make salads, but if they're judging me on dessert, soup, and entree, stop making the salad, right? So I really had to focus on making sure I wasn't doing what I wanted to do, but what the judges expected to see. In terms of the physical architecture, I showed a decomposition here with a relation map, again, just giving you insights into the type of things that were in the context, and then showing that some of these were optional, that the nuclear waste storage, the gas power plant, the coal power plant, these were placeholders where analysis done with a trade study tool like Phoenix Model Center or some equivalent could be used to fine tune the actual delivered architecture that we would actually construct. So in other words, these were all the stub placeholders necessary. So if we determine that, yes, we need, 3 solar plants in this time period, that sort of thing, all that can be driven by an automated trade study. Again, not my area of expertise, but I can put the hooks in place to enable that. Again, we just had a handshake between the actual physical architecture and the logical architecture to make sure there's nothing lost, and then mapping the operations between the logical and physical system elements as well. So again, ensuring traceability every step of the way as we change layers of abstraction. And then finally showing the satisfaction of requirements, again, from the various property view the other way. So instead of looking from the requirements to what satisfies them, we're looking at the value properties to what things they satisfy. And again, annual rainfall is just a value property. It's not tied to a requirement because it just is what it is. So that's why there's a gap on the right. I also decided to stretch a little bit and show failure analysis. So in this case, this is a coal power plant showing a state-based approach to failures. And you can see here that if we're out of coal, that leads us to a failed state, and we recover when coal is made available. I also looked at inoperable, and notice we have a terrorist attack or cause equipment failure. So a variety of different ways to show something could become inoperable. We also have coal plants outlawed. And so again, using this approach, I can show that if coal plants are outlawed, that function to provide electricity is no longer viable from this particular system element. So just a look at how you can leverage an existing model to do some adjacent analyses. This was the stub for the quality of life analysis. Again, an abstract concept, but thinking that we would work with sociologists or something to work out some model for looking at tax rates and for both individuals and corporates, and some quality of life index related to how are you able to enjoy living in Mesa Cerveza. And the freedom index would be some sort of composite of water restrictions, power restrictions, that sort of thing. So again, trying to show that with the right expertise, you can do some non-traditional analyses based on a system model. So things I didn't put in were things like the negotiated water amounts and power generation per source per year. I would add those if I'd had more time. I didn't also go in depth and make the detailed units and value types and quantity kinds. I normally would make custom ones to support the analysis. In this case, I just used stock things that came in the default tool installation. And again, I try to show the traceability of the source content is either direct or very easily inferred with a multi-hop meta chain and magic draw. So you can start anywhere and follow traceability any distance upstream or downstream. At the end of the day, I ran the validation suite with 225 rules. There were 0 errors, and the 125 information warnings were primarily related to inputs and outputs of functions not being mapped to interfaces. But as I said, I was not being graded on that, so I just stopped and didn't do that. And so that's basically where I ended up with my model. And with that, I'm happy to turn it back over to Rick to talk about judging.
All right, thank you, Michael, for the very detailed and very extensive presentation on what you came up with for the contest. So before we turn it back to Rick, I do have a poll question for the audience. So do you feel your current work allows you to showcase your modeling skills as a systems architect or an MBSE modeler? All right, so we have the results here. So a lot of members in the audience are not an architect or modeler, and that's fine. Well, welcome. But yeah, I'm definitely glad to see that you have an opportunity. A lot of you have an opportunity to be able to showcase your modeling skills, and that's definitely a very good thing at your job. So thank you for that. All right, with that, I will go ahead and pass the mic back to Rick, so you can go ahead and
okay, and let me see, I should be able to show. So what I want to do now is just want to give you an overview of the results, the kind of things that we had, the contestants and and some observations, maybe the best way to put that. I'm not going to go into a whole lot of depth, and I'm probably not going to show any of the other models that were presented other than what we've already seen, because I haven't talked to the teams about sharing them, unless there's a particular question about it. But here are the contestants. Do you remember, Dan, you know Kelly's first name? I've forgotten. I don't. He withdrew early on because he had a work commitment that popped up, and it happens. We had Bill Ozier, we had Daniel Spencer, of course, Mike Menarchik, and then we had teams. We had a team from Noblest. There were 3 people in that one. We had one from SAIC. The last 2 teams there actually came up with team names. I thought that was kind of clever. 2 birds in 1 stone. That was SAIC, 2 people. Boot, Scoot, and Boogie, they each named themselves, and they're in the Sandia team. So at least they had a sense of humor about it. Noblest was the only unnamed team. That's okay. And I know it's going to be inevitable. People are going to ask, well, what tools did they use? Okay, well, I'll tell you because everybody's going to ask it anyway. Most of the, well, 2/3 of the contestants used Cameo, and 1/3 used Genesis. Okay. Now I don't know what that says about Spark-CA, and I don't know what that says about Rhapsody. It's with only 7 contestants. It's hard to say that's a big enough sample size to draw any meaningful conclusion. But I will say that this is not unexpected. Okay. So with that, let me just give you some more ideas of kind of what happened. Oh, let me start by asking this question that I just want you to think about, because it was a question on the back of my mind, and I'll try to answer this by the end of my presentation here. Would you think that in this time-constrained contest like this, that a team would do better than an individual? There's this very short time constraint, but then there's some challenges, like you need to maintain a consistent vision and stay focused on the problem. Now, teams can do that, but they need to practice, right? And so that's just something to think about. It's very easy for me, if I'm doing this by myself, to get sidetracked, right? Or to go down deep in the details, put unnecessary details in. Mike had mentioned to you the job he had to do to not put detail in that wasn't going to be measured, okay? And that was a problem for some of the contestants, that they had a lot more detail than they needed. In addition to doing the engineering, there's also the project management aspect of this. As Mike had pointed out, there's a time to do the plating, the time to say, okay, pencils down, let's just take what we got and make it presentable and talk about how we're going to present it. So there's a time management aspect to it. There's also this issue of balancing innovation and plausibility and risk, okay? And that varied from team to team, okay, or from contestant to contestant. And so I just, in the back of your mind, I want you to be thinking about, well, do you think a team would do better or an individual would do better, right? If an individual is suitably focused, they might do better than a team because they could, move more quickly and not have to have debates. But if a team is well structured, they might do better. Okay, so just think about that, and I'll try to have a conclusion by the end here. Okay, so with that said, here's some common themes across all of the contestants. Every single contestant built a good model. There were no clunker models. Every single one of them had excellent merit. They followed their own processes. They had their own consistency. They attempted to address almost all of the evaluation points one way or another, okay? The models they showed us, or the excerpts from the models they showed us, were all clean and understandable. There wasn't any junk, okay? Now, we didn't go take their model files and look for things like unnamed elements and missing links and things like that. We looked at their output. But I was very impressed that the modeling seemed to be good, solid modeling, okay? Most of the contestants conducted very comprehensive analysis of the requirements we gave them and spent a lot of time decomposing those requirements into things that made sense. They almost every contestant built a system context model, which is one of the things that I'm very hot on when I teach my students system modeling and BSE, that you need to put your system in a context, and that context then needs to be related to requirements and to use cases. And most of the contestants did a very good job of doing that. Now, most of the contestants performed some level of functional behavior analysis. There was a functional architecture requirement or evaluation point, so that kind of may have spurred them on, but it was pretty clear that most of the contestants, it was actually part of their process. They were going to do some sort of functional analysis or behavior analysis or behavior diagramming or activity modeling or something, right? Use case modeling, etc. Okay. But that said, most of the contestants, but not all of them, had did the following things: the linkage to requirements, cost, budget, and schedule. There's some contestants that didn't quite get the cost, budget, schedule linkage to work. Most of them did risk management in some sense. Some of them were kind of superficial. Most of them did some sort of verification, but there were some that didn't. Some provided some trade-off analysis or of some sort, or at least mentioned that they were going to do it. Some were much more specific about it. And most of them provided some sort of analysis hooks for how they're going to evaluate constraints and attributes. And so that was common. That was pretty good. So what are some general observations then about how we went through the evaluation? Well, I got to tell you, even with the judging rubric that we had, you'd think that would be enough to provide, good discrimination, but it really wasn't. Most of the teams, most of the contestants did very well in the judging rubric, and so we had to add a couple of intangibles and to address that and become a little bit more refined in the way we did that. It was a lot harder to actually select the winner than we thought it was going to be, and required all the time we had to actually select the winner, which was kind of surprising. We did have one individual that focused specifically on an advanced technology, and this I had a lot of sympathy for this contestant, because it was a lot like what I would do. I focused very much on a specific technology at the expense of the requirements and the programmatic constraints, and then ran out of time. Okay, that's the kind of thing that would happen if Mike had decided that, I'm going to build the IBDs, I'm going to put those that flow modeling in there, and didn't have time, would not have had time to finish what he did. And so that was one of the dangers that we kind of expected. Okay, one team took advantage of an unclear assumption that to propose a very low cost solution. Now, I think that's great. I really appreciated the audacity of doing that, saying, well, what if, what's the elevation of this lake, and what's the elevation of this lake? You didn't say it anywhere. So they come and ask me, I said, well, it's not in there. It's not in the rules. I can't change it. So make an assumption. Oh, well, our assumption it's high enough, you can just gravity feed. Oh, okay. So they made an assumption, okay, but they didn't. The judges didn't really feel that they had addressed the risk of those assumptions in their analysis. But I really appreciated that audacity. Yeah, and one team actually had a slide in their brief saying that they could spell Krajmalnik, which is Enrique's last name. I thought that was kind of clever. Anyway, but it's not clear immediately that the teams or the individuals did better. Okay. I'm still trying to process that, and I would invite you to comment or ask questions about that as we finish up here. Okay, some of the key discriminators that actually made a difference in the grading in terms of who won what. One individual specifically developed requirements for verification requirements. That was pretty impressive. Okay, these are not all the same people, by the way. These are actually pretty much all different. One team specifically modeled both at the as is and the to be architecture. Okay, one individual and one team specifically modeled logical and physical architectures. You saw that Mike was one of those because he did a logical architecture. One individual ran self-consistency checks and provided metrics, and you saw that as well. 0 errors, 125 warnings based on the model consistency checks. One team specifically modeled multiple candidate solutions in the trade space and was actually able to show how that trade space might be evaluated and changed. And it was very specific, and I was very impressed by that. And then, of course, the one team I mentioned demonstrated both audacity and innovation, okay? So here are the winners. Of course, you've seen Mike and give his presentation. The team winner was Team Nobles. It was a very impressive, comprehensive overview that really distinguished them. And they were able to meet in any one single area. They probably weren't the best, but overall they really covered everything. So that was very impressive. And then 2 birds, 1 stone. Those guys, they were audacious, and I got to say I appreciate that. With everything else, their model was still very good, right? It was just the risk of their solution that kept them from actually getting the previous award, the team award. With that said, let's see, what else do I have to tell you? That's it, okay? So I guess what I want to do now is turn it back to Daniel, and we'll open it up for questions.
All right, thank you, Rick. So one last poll question before Q&A. So which is scarier? All right, share the poll result. Not sure if you can see it on the screen.
I can see it.
Yes, we can.
All right, so with that, I can go ahead and share screen.
So while Daniel's doing that, I will make one observation. You know, in the case of my team that came up with most innovative, they were able to do more than a single person could, because they did segment some of the tasking and actually built out an entire test plan using another part of our digital engineering tool chain. So back to Rick's comment about individuals versus teams, I would argue if the team can manage not to step on each other or has clear segmentation like that, they will definitely outperform an individual. But back to you, Daniel.
Thank you, Rick and Mike, for that. So we'll start with some Q&A here. So first question. Okay, so how many teams competed? So three teams, 4 individuals. What was the range of modeling solutions and technologies what that were used? So we saw a mixture of Genesis and Cameo. All right, so next one. This is for the organizer. Will you encourage people to participate in the competition? This is a good way to show innovation modeling. So I guess I'll hand this one off to Rick.
Absolutely. I mean, I certainly want to do that from my instructional role in University of Arizona, but I would also encourage that from my connections through the working groups I have at the Object Management Group, and for the various consulting engagements I have. Yeah, I would certainly encourage people to participate in the competition. Now, with that said, I will say scaling this competition up to more than 7 contestants might be a little difficult. We will have to have a much more focused judging team. Okay, if we anticipate 20 contestants, for example, which is not unreasonable. Okay, how we get through 20 contestants in a day, it would probably end up being a 2-day event. But yeah, so I would certainly encourage it, but there's implications of a broader or bigger competition. Still, first step, I think this is a great first step.
All right, so question for Mike. So obviously at the start of the competition, you probably recognized who your rivals were, right? So did that knowledge affect your winning strategy?
Not really. I mean, to me, I was competing against the clock and the problem itself, right? I mean, I just didn't worry too much about it. Yes, I knew some of the folks there. They knew me. I wouldn't say anybody was in my head per se. It was more of let's just focus on the outcome and do the best model I possibly can with the time I've got.
All right, perfect. Thank you, Mike. The next question is probably good for Rick. Did anyone use additional tools to do design space trade study? Did anyone specify a product line or feature model in order to explore design choices rigorously?
Well, I don't think I have a simple answer for that. All of the teams use MS Office, all of them. Okay. They had to use PowerPoint as that was the deployment mechanism for their solution. But all of them used Excel. I don't know, Mike, you can comment whether you used Excel or not.
Yeah.
But
Well, I
yeah,
would say, nobody was using like big liver gears or
right.
pure variants. It was hard enough just to get the base architecture done in 6 hours. There wasn't a lot of time left to really structure, 150% models and everything else, which is, I think, what the customer or the question was getting at.
But I need to point out that Mike, you had mentioned the idea that you were setting up for trade studies, you were setting up for analysis.
Yep.
There are a couple of teams that did a really remarkable job of doing. The SEIC team did a great job of setting that up. The Sandia team, I mean, that's what they do for a living, is do these detailed analysis. And it was pretty clear from their Genesis model, they had set it up to be able to link it into analysis tools. And so I think most of the teams with that kind of experience had that mindset, if that makes sense.
All right, so we only have time for one last question. So this one is for Rick. So as a judge and also an educator, do you think that this type of MBSE competition with a real world problem will promote college students' enthusiasm and also curiosity for SE and MBSE as a career choice?
That's an excellent question. I don't think I have a pat answer. I would like to say, well, I certainly think my students would appreciate it. Okay. I also think that it provides a rich set of example problems, and if the participants, the contestants, are willing to share their models as examples, it provides something that it provides a rich way of comparing modeling techniques and styles. Okay, now that opens those competitors up to criticism, and so I wouldn't do it without their consent. But Daniel, I think it's worth pursuing that and saying, well, as competitors, are you willing to make your models available for others to see and to review? But enthusiasm, absolutely. I think my students would love this.
All right, perfect. Thank you, Rick. So that's all the time we have for today. If we did not get to your question live, we will follow up with by email after the broadcast. And let's see. And with that, that concludes today's webinar. So thank you a lot. A lot of thanks to Mike and Rick for sharing that interesting information with us. So this is Mike and Rick's LinkedIn information so that you can continue the conversation. And I have also included Brian Selby's contact info since he was the primary force behind this competition. And then he can answer any questions you might have about it. All right, so I hope that everyone found the webinar interesting and helpful. An on-demand version of the webinar will be available on Tuesday, September 26th. For those who want to view it again or share it with your colleague. This event is a part of the Zuken 2023 Technical Webinar Series So please visit our library of technical webinars on the web for more information about other topics. Now, the next webinar, we will discuss the most innovative solution to this systems architecture problem, which will be held on September 20th. So stay tuned for the invitation. All right, and finally, please take a moment to let us know how we did on the exit survey. It's a quick single question, and we'd really appreciate your feedback.
The next webinar is held on November 1st. You said September.
I'm sorry, November 1st. I misspoke. September 20th is today. All right. Well, thank you again for attending, everybody, and have a great day.